Good evening. This is a requested help video for Stats 243A, Week 2 homework, and problems 1, 3, 9, 1, 3, 4, 19, and 20. All right, so let's take a quick look at what we got going here. Problem number 1. To the psychology class students, took a standardized test. The scores are summarized in the frequency distribution below, right? And then it says the scores are also described in the cumulative table below. What is the missing value in the frequency table? So they're looking for this value right here. So notice that how these two tables correspond. Up to 209, 20. Then when you add these two together, you get this 35. Then when you add these two together, 35 plus 19 is 54. Now when you add that 54 plus X more, you get up to 72. So what's the difference here? What was the difference that made us go up to 72? If I subtract 54 from both sides, I'm going to have to do some borrowing. 18. So my missing value is 18. Okay? I just want to do a quick note again to tell you what this is. The frequency distribution is just a count table. It says 20 people got between 200 and 209, 15 people between 210 and 219, 219 people between 220 and 239, and so on. But the cumulative means to add them up, to accumulate, is a running total. So we start with 20, we add 15 more, now we're at 35. We add 19 more, now we're at 54. We add this 18 more, now we're at 72. If I put 18 here, I could add it all up, and then I could figure out how many we were at total. And then I could also figure out what that n was if I wanted to, but that's not what they're asking for. All right, let's take a look at problem number 3. Here's 3. All right, so what do we got going here? A researcher for the EPA measured the amount of arsenic in the water near a sewage treatment plant. Well, that is not a fun thing to have in your water. Over 5 days, he took 20 measurements in parts per billion. His sample data is summarized in the ogive graph shown below. Remember, an ogive graph is a cumulative graph. So, how many measurements were taken from the time frame within 60 to 65? So here's 60. Here's 65. Right? There's my parts per billion. I'm going to go over this way. We only got 15, 16, 17, 18, 19, 20. Go over this way. So this is 15, 16 and a half, 17, 18, 18 and a half. So in this range, we went from 16 and a half to 18 and a half. That's the jump we made. So we made a 2. We made a jump of 2. Okay? Hopefully that's helpful for you. And 4. A health insurance company was looking for the age of customers that they visited sorry, I should do this on a different slide. Here we go. A health insurance company was looking for the age of customers that they visited in the emergency room. They took a sample of 40 emergency payments over the last week and recorded their age. Their data is summarized in the frequency distribution polygon shown below. Very similar to histogram, this shows the distribution in a connected line graph. How many patients were within 45 to 50 year olds? So I go up here. And 45 to 50. Right. You'll see this middle line right here, where you take the midpoint and you connect it. So this would look like, so this would be like kind of like this, and this would be like this. The midpoint right there. And there's 9. 9 patients in that range. Because these dots represent the midpoint of the range, which is what you're reporting for that class. And moving on to number 19. Another ogive for us today. Our company is trying to optimize a battery for a new product, and your team has been investigating the recharge cycle. You want to make sure that the battery does not overheat during recharge. You keep track of the temperature of the battery as it charges. Your data is displayed in a cumulative frequency chart below. Relative cumulative frequency chart, also known as an ogive. Right? And our question here is disappeared. Let me see if I can get that question. One moment. Okay, so let's take a look at number 19. We've got this photo here now. My eyesight's not very good, so I actually need to blow this up a bit. Estimate the proportion of batteries that charged with a temperature of 90 degrees or less. So I look for down here where it says 90. I go up here to 90. Look like 45%. So 0.45. Again, we're looking at a decimal between 0 and 1. Then it says, estimate the proportion of batteries that charge with a temperature above 94 degrees. So if I go to 94, 75 were below 94 degrees. So that means 25% were above. 1 minus 0.75 is 0.25. What battery temperature represents the 55th percentile? So I look over here at 55, go over here, drop down, and that looks like 92. And then move over to the next slide. They did give us this range here. The highest number of battery recharges in it. Looking for the largest slope, essentially. Let's go back and again, the steepest slope will end up having the highest jump in the highest range of battery recharges. Okay, so this final graph asks us to create an ogive. This is a fair amount of work, just FYI. I mean, if you're doing it by hand and you're doing it well, which we will. So I want to just tell you a cheater's way to do this. First of all, these can't be ogives. Ogives have to end at 100% of where you're at. So, and the cumulative frequency has to be 100% like at your maximum. So just saying that. We want 8 classes. So it looks like they have designed our classes for us. Our minimum here is 38, it looks like. See any smaller than 38? Nope, 19. And our largest looks to be 17. This one doesn't start right. Like our smallest is 19, so it's got to be under 100. I don't see where our maximum is here. Just checking for a maximum. Yeah, there's our 715. Yeah, so it looks like it's going to be this one just by looking at the max and min and also knowing what an ogive is. If you wanted to go through this whole process, I'll just run through kind of what you would do. You would set your classes. We would go 0, 99, 100 to 199, 200. Well, we want the upper class limit, so let's set that. 1 to 100, 101 to 200 to 300 to 400 to 500 to 600 to 700 to 800. 6, 7, 8. All right, so we got slightly more than 8 classes. Data using 8 classes. They went 100, 200, 300, 400, 500, 600, 700. They just stopped at 700, which really is not great because we have 715. So they're using essentially 9 classes here, which is sloppy on their part to say 8 classes, which it's not, but this is how you would do it. We're going to use 9 classes based on their classes on the bottom here. And then we would just go through and we would start tallying. 137 goes here, 20, 117, 141, 675 is between 607 and yep, right there. I'm sorry. 675 is here. This is from 601, 701. And not there. 675, 617, 312. The brain's not firing on all cylinders here. 312 goes here. 58 here. 19 here. 238 here. 188 here. 168 here. 52 here. 65. 48. 167. 292, 47, 196, 432, 203, 629, 286, 239, 386, 38, 509, 262, 248, 63, 204, 48, 58, 358, 2, 322, 248, 688, 202, 561, 356, 45, 60, 126, 426, 109, 378, 715, 433, 44, 85, 190, 256, missed that one. 589, 405, 471, 15, 15, 10, 12 more, 10, 8, 13 more, no, sorry, 8 more, 5, 6, 7, 8, 3, 3, 4, 1, 15, 27, 37, 45, 48, 51, 55, 56. So this one ends right at 56, which is good. So our first jump, 15, great. Next one should be 27, looks good. Next jump right here should be 37, then 45, so on and so on. So we're all good. Anyway, that's how you would do it by hand. All right, hope you guys all have a great night.